Hi everyone, thank you so much for joining me. This talk will be about Terraform practices, the good, the bad, and the ugly. Terraform is a great tool. It is used widely across the world. This talk will cover not only specific bits and pieces regarding Terraform usage and practices, but also, hopefully, will make you think about your unique use cases and scenarios and help you see the big picture and utilize Terraform in a broader context rather than just an infrastructure as code tool. So hi, first of all, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. I'm a DevOps culture fan. I think this is what helps companies achieve great things. I help co-organize conferences in Israel where I live, DevOpsDays Tel Aviv and StatsCraft Monitoring Convention. We just had it this Thursday and it was awesome. I'm a mentor in courses and communities in Israel, tech communities for women and for open source. And I'm a lead singer in a cover band, as you can see in this picture, which is a lot of fun. Okay, so Terraform implementations can be good, can be bad, and sometimes ugly. And we will cover everything here. And just a disclaimer, I'm gonna show mostly examples from AWS, but Terraform has a lot of providers for GCP and Azure. So it just examples, but it applies to every cloud provider. And I only used Terraform open source version. So I don't know if what I'm gonna say here applies to Terraform Cloud and Enterprise. I assume so because it's like tiers, so it only levels up, but just FYI. Okay, quick wins. Quick wins are things that you can do and achieve in a matter of minutes to already use Terraform in a great way. So first of all, versions lock. When I say versions lock, it's like same as uh, when you lock versions in your requirements.txt or packages JSON lock. You have a version with a complied syntax and features in it, right? So we need to lock the versions in order to let Terraform know that this is what we expect to do and this is how we expect to write the code in the syntax that is suitable for that version. So versions lock are available on modules level, on providers, and on Terraform versions themselves, like you can see in these examples. You should always lock the provider versions because as you can see in this meme here by Anton Babenko, who's like a Terraform celeb, and I also had the privilege to meet him, and he's a fabulous guy. There are a lot of issues with Terraform providers, also with AWS provider, and it's best to lock versions because it's best to deal with the devil you know, as opposed to not lock your versions and not know what you can do or not do. So if there are issues, it's best to know them and work with them as opposed to deal with the unknown. So in regards to versions lock, always lock the modules, providers, and Terraform versions. The bad thing here is to lock in a way that will still allow breaking changes to occur, because if you lock to a major version, then that's good. But if you lock to a minor version, then breaking changes can still happen. So always try to lock with major versions only. And the ugly thing here is to have no versions lock whatsoever. Believe me, a lot of syntax issues, a lot of issues in general. So avoid that. Next up is tagging resources. So in my opinion, it is a must implement practice because it allows to filter your cloud provider expenses and sort them by tags to distinguish between resources. And it also you gain visibility on ownership and overall projects by tagging according to a logical breakdown. So this is some examples of tags that you can use. Owner contact, managed by, if you create it with Terraform, so managed by Terraform, and then you can distinguish between resources that were created with Terraform and manually. Environment, business unit, service role, so all of these tags are helpful for cost management and to know who's the owner and stuff like that. So the good thing is to tag everything that you can, because trust me, everyone will thank you for that. You can use default tags on the provider level. So for example, if I put the managed by Terraform tag in the provider level, it means that all resources that I create under this provider will automatically get this tag, which is awesome because it's like You set it up once and forget about it. Do PR enforcement to fail PR merge if tags weren't added to a certain resource. I'm gonna cover I'm gonna cover practices enforcement later on. The bad thing here is to tag inconsistently because, as we know, consistency is key. So always tag consistently. And the ugly thing is have no tagging whatsoever. It will be hard to keep track of what's going on in your cloud. So always try to tag. And the last thing in the quick win section, remote state. By default, Terraform works with local state. You can define a backend, S3 for AWS or a GCS for GCP, and then the state will be kept remotely. So the good thing is to have the state remote and secured. Also to have state backed up. For example, if you use S3, then enable versioning and ensure that state lock occurs when you run Terraform apply, because if not, then there could be conflicts if someone else runs Terraform as well, Terraform apply. And the bad and the ugly things are basically the opposite. So local state, because then, it's not good. State is remote but not secured or backed up could also be a bad thing. And if the state doesn't get locked during Terraform apply. Okay, so we talked about quick wins, right? Things that you can achieve in a matter of minutes. Let's talk about second nature, stuff that you should do in your day-to-day and have awareness in your day-to-day in regards to Terraform. So using community modules versus creating them yourself. There's a old saying goes with, do not reinvent the wheel. If something already exists, so just use it. And using official community module is good because it is proven over time, it is supported by the community, and you eliminate the need to support it and keep it up to date because there are other people that are doing it for you. And a lot of well-known cloud providers features are already covered by modules. So do your research, check available modules before implementing yours. So the good thing is to use official community modules wherever possible, because sometimes the use case doesn't fit, and that's okay. But if it does, so just use a community module. The bad thing is to write your own module. Sorry about that. Writing your own module while official one exists, but if you still maintain it as such, then that's okay. And using community module without version lock, as I mentioned before, it could be bad as well. And the ugly thing here is to write your own modules and have no checks or consistency whatsoever, and have no code practices applied. I'm going to speak about it also later on. And the thing about community models that I will also touch a bit later is that community models usually use enforced linters and formatters and logical checks because they want to maintain important aspects to allow new users to get easily involved and contribute to this model and use it. So community models are awesome, and if you can use them, please do. And if you have to create your own models, then make sure you make them stateless and clean and generic, and you do not repeat yourself if not needed, and they are simple as possible. And use enforcement to maintain their quality. Again, I will discuss it a little bit further. And as I said before, we have the practice enforcement that are applied on a lot of or all community models. So same principles should apply to your internal models as well. Next up is variables versus locals. So variables are pretty straightforward. You just set the values up and that's that. And locals are a bit more enhanced. So unlike variable values, local values can use dynamic expressions and resource arguments. And locals also don't change values during or between Terraform runs, such as plain or apply or destroy. And you can use locals to give a name to a result of any Terraform expression and reuse that name throughout your configuration. Like in this example here, I've defined tags, and then I have a condition to create a tags, which means like merging from one variable to another, merged together, and then this tags local will be used throughout the entire module that I'm using. So on the module side, you should use variables as a needed settings for module config. And you should always set default or validation on the variable, because if not, if someone doesn't pass a value to the variable, then the module will get break. So always do that. And in regards to locals, it should always be considered as a constant to be honored or relied on. So for example, if I have a model to create an S3 bucket, then I can have, like, let's say I want to have a naming convention for all buckets that are created with this model. So I can do it with local, define the convention, and then someone uses it, and that's awesome. On the live side, and when I say live, I mean where I call the modules. If you use variables once, you can just set default on a variable. But if you use it per region or etc., then you should use tfvars file. You should avoid using locals because we want to keep live as simple as possible with little or no logic at all. So you should avoid using locals because locals are usually things that have conditionals in them and stuff like that. And use data sources to pass their outputs to the module. Okay, so to sum things up in regards to variables and locals, use tfvars where necessary. Utilize envvars because if you have environment variables, then you can use them as opposed to just adding new or more variables that you need to maintain. Use locals to de-hardcode names or tags or whatever which are set only once, or to decrease code repeatability, and keep things generic as much as possible. The bad thing here is to use multiple locals block if not necessary, because then again it will be hard to read and maintain, and ignore environment variables because then you will need to create more and more variables. And the ugly thing here is to hardcode values on variables that should support multiple scenarios, because that's the thing with variables, right? They need to change. So yeah. Okay, next up is files structure. So we need to structure our files in a module or in the live side, because we want to have a better logical arrangement and easy management. So as we know, Terraform will execute every file that has the suffix of TF, but we want to arrange the files for us human beings to be able to maintain it better. And for that, we can take example from the community standard as well. So we have main for the main logic, and then variables, data, and outputs. And then we can also break it down a bit. So if, for example, I have a module for creation of a VM, I will put this logic in main.tf, but then peripheral stuff like security groups or a load balancer, I will put in separate files. And also, if the module gets complex and we want to maintain it better, we could break it down to sub-modules. Also, example from community standard, take, for example, the VPC module. It has a sub-module of VPC endpoint, or the EKS module. It has sub-module of creating of the new node pools. So you always need to think about how things will be better maintained and manageable. And that's why, and then structure the files according to that. And it's best to have naming convention which reflects the actual purpose of each file, and that way we will get a decent logical arrangement for faster access and better readability and cleanliness of the code. Which leads me to my next thing, which is applying classic code best practices on Terraform. So yeah, relax. We all know that Terraform is not a pure programming language, but similar rules of writing code apply to Terraform as well. Terraform progressed over the years in a way that adapts code best practices. For example, you might remember that before Terraform 0.13, you can't even use for each for modules. And when Terraform 0.13 released, then HashiCorp finally introduced the ability to loop over modules with a single module call. So that's why it is always a good thing, and that's why you see only the angel here. I can't think of a bad thing to say about applying classic code best practices on Terraform. It's only good in my opinion. So you should always apply best practices on Terraform code. So keep it in a source control management, keep the code as simple as possible. Do not repeat yourself if you don't need to. Functional programming aspects and principles can also be applied here. The code should be idempotent. And in regards to human and clean, I want to um, quote something from an article I found by Tixon Guo. I hope I mentioned his name right. He said, and I totally agree, that the computer that processes your code doesn't care if the variable names are ambiguous or inaccurate, right? If used correctly, it will still get executed. But since human beings are the ones to maintain the code, we need to make sure it is readable. And things like refactoring and clean code and naming conventions and modules and stuff like that are invented so that we human beings can read the code better for the sake of us humans and not the computers. So that's why it is very, very important. Okay, so we covered quick wins, stuff that we can do in a matter of minutes to use Terraform in a good way. We covered second nature, things that we need to be aware on our day-to-day when we use Terraform. Let's talk about the long haul, things that we need to plan ahead when working with Terraform. So structuring your Terraform code base, how do you structure it? There are a lot of ways to do it, right? So I want to show you how we do it in weeks. So in weeks, we have, sorry for that. Okay, in weeks, we have team, project, cloud provider, and region. This is the structure. So a lot of department in Wix uses Terraform. And this is the structure for each team, and each team manages the code separately. So this is an example. So we have live and modules, and then BI for team, Airflow for project, AWS for cloud provider, and US East 1 for region. Why did we choose to do it that way? Because two main reasons, actually. One, to have Terraform as a platform, self-service Terraform. All departments in Wix uses Terraform. They maintain their own code, and this is awesome because they have independence to do it, and we have an aligned way to do things in Wix, so it is better. It is really helpful to do it like that because it's easier to maintain. And the other reason is that in this structure, the state files are kept in US East 1 level. So it means that the state file is only for BI project, Airflow project in BI team in AWS US East 1 region. So small states are very, very important because that way you avoid big blast radius. And as you know, Terraform creates dependency trees, and sometimes we need to help Terraform do it in a proper way. So in order to avoid invalid dependencies and issues, then have the small state set up, and it is awesome. So that was about structure of the code base. I want to talk also about workspaces because it's not really related to structuring, but it is something that Terraform offers, and we should talk about that. So workspaces are a unit that isolates the state. And so if you run Terraform plan, Terraform will not see any existing state for this configuration from other workspaces, only the one that you work on. So when we should use workspaces, when we have the same Terraform config for different customers. So let's say each customer is a GCP project. Each customer will be a workspace on its own because the Terraform config is the same. Another case, which basically couples with the previous one, when we have the same service for different regions. So let's say all the customers need to use the same financial service or login service, right? And we have it per region. So also this could be in separate workspaces. Some notes about workspaces. You should consider using Terraform wrapper to avoid human errors because how to use workspaces with CLI Terraform workspace select X. If I forgot to do this select, it's a problem. So, and which leads me to the next bullet, that you have less visibility. You use CLI, and if you haven't used the Terraform workspace built-in variable in the code, you don't even know that you have other workspaces set up. And even if you do, and you do a Terraform workspace list to see all the workspaces, you don't know if they are actually in use or not. So you have less visibility and a lot of other challenges when working with Terraform workspaces. So you should really think about it thoroughly before you go down this path. And also, another thing about workspaces is I want to read you something from the Terraform docs. So it says, use workspaces to manage multiple non-overlapping groups of resources with the same configuration. So it suggests that these usages are qualified, right? Multiple environments, multiple regional locations, multiple accounts or subscriptions, like I showed before, all good. But then also from the Terraform documentation, it says that for multiple deployments of the same infrastructure serving different development stages, staging versus production, named workspaces are not a suitable isolation mechanism for this scenario. So I don't know. In my entire career, I haven't used the same infrastructure for both dev staging and production. So I don't know if they really refer to that or to just the separation between staging and production. I'm not sure, and if I'm not sure and it raised a question for me, maybe it will for you as well. So just bear that in mind and really think things through before you plan and work with workspaces. And at least we can all agree on at least one workspace usage. Workspace could be like a side branch. So you have a new syntax that you want to test out. You can create a new workspace, do whatever you want, apply it, blah, blah, blah. And then once the syntax and the code tested out okay, then you apply it on the default workspace, which is the main production infrastructure. Okay, so to sum things up in regards to structuring your Terraform codebase, if you do it and you plan ahead and you really think things through in regards to structuring the codebase, it will allow you to set up small states, which is good because then you avoid blast radius and all the bad things that could happen with that. And it will allow you to set Terraform as a platform and enable others in their Terraform journey and have an aligned way to use Terraform and then better manageable platform. The bad thing is that if you don't plan ahead, then organizational changes could require you to restructure the code, which is not good. We want to restructure things because of things that we plan and not things that that caught us off guard, right? And another thing which is bad is use workspaces for the wrong reasons, like I showed before, or to think about it thoroughly. And the ugly thing here is to structure the code base in a way that will allow huge states, because again, big blast radius, trust me, you don't want that. The next thing is Terraform execution. So you should always aim for a remote execution because that way you avoid the need of local credentials and local configurations, and that's awesome. And also remote execution means you have audits for anything that you do in the code and in the environment, in the infrastructure. You should run apply with a plan file because that way you know exactly what you're applying. And you should set up Terraform timeout that seems reasonable for you because, for example, I created AWS auto-scaling resource and I used spot instances and the price wasn't right, so I had to wait and wait and wait, and it's not good. So set up a timeout that is reasonable for you. And the ugly and the bad thing are basically the opposite. So execute locally. Again, you will need local credentials and local configurations, but the ugly thing here is to execute locally and run Control-C when you're running TF, because when I started out with Terraform, I didn't want to wait for a timeout to occur, so I did Control-C and then it messed up my state. I don't know if they fixed it by now or not, but I don't want to find out, so I urge you not to do it as well. Okay, so the next thing is practices and enforcement. I think this is very, very important. So as I mentioned before, community modules have practices enforcement in place to check and follow practices of readability and cleanliness of the code. In order to keep that in check, you should use enforcement because we want to have a higher quality state of code, and we want the code to be readable and clean. So that's why they have practice enforcement, and I'm going to show you an example right now. So this is an example from the AWS autoscaling module created by Anton Babenko. And he basically added tests to make sure the code is good, aka did the contributor formatted the code, did he or she or they added documentation, write a working code and use TF-lint for that. So these are only examples, good examples, but you basically can apply any best practices and guidelines that you want. Okay, for example, in Wix, we have a practice enforcement that checks if a PR, that checks in a PR if the code has tags, if the resources has tags in them. If not, it will fail the PR because we care about tags and we want to make sure all resources that were created with Terraform have tags. So you can use whatever practices that you want and enforce any guidelines, any best practices that you want and reasonable for your company. And this is awesome. And again, these simple checks can easily remind developer to keep a high quality standard of a PR as best as possible. So also here for practices enforcement, I don't have any bad thing to say about that, so only good. So have pre-commit or merge linters, formatters, and logical checks. You can do it with GitHub Actions or CI pipeline checks. For example, in Wix, we have, when I open a PR, then there's a GitHub action that runs Atlantis. It runs Atlantis plan. I see the plan. I see that everything is okay. And then I type Atlantis apply. Then Atlantis do two things. Both merge the code to main and apply the code. So this really helps us make sure that main is the actual environment to avoid drifts. But if you still have drifts, then you can create a Slack bot to report any drifts. And on the right, you can see open source enforcement and helpers that could help you in your journey of integrating practices enforcement in your code base. Okay, so I covered a lot of things, I know. A lot of things because I love to give value. So let's take it down a notch and think about one thing. When you work with Terraform, you should ask yourself, how do you envision the infrastructure and the company needs? You should think things through, and planning ahead will allow you to enable others on their Terraform journey. You will be able to set up guidelines and best practices of your own, like tagging usage, structuring modules, and Terraform utilization by others. I'm not sure if this is big enough, you tell me, but these basically are the things. You should take into consideration use cases and your pain points and Terraform constraints, and where do you see the infrastructure management and the company needs in the long term, and plan accordingly. So if you plan the code-based structure, you can set up Terraform as a platform and small state files. And if we wouldn't plan ahead in Wix, we wouldn't be able to set up Terraform as a platform. So planning ahead is very, very important. And even if you're a startup, you should think about scale and how should you address and prepare for changes to come, and then you'll be able to utilize Terraform in the best way possible. And practices enforcement will help with that. Startups, corporates, practices enforcement will make sure that no matter how many people using Terraform in your company, 10 people or 1,000 people, everyone will use it probably the same way because there are practices enforcement to make sure the quality of the code remains. So I want to quote something else from Dixon Guo article because it is really great. I encourage you to read it. So basically he said, and I totally agree again, that programs evolve and code changes, and it is really uncommon that you write Terraform code and it stays the same, right? Because this is not how projects work. If that was the case, we wouldn't be even talking about Terraform practices here. All of us would use Terraform in the same way, write the code, and continue with our lives. We will always have projects because businesses want to improve, and changing from the current state to the next desired state is a project. So you should think about how you structure Terraform code base and treat Terraform in general, because that way you will allow projects to evolve and get introduced and help your company improve and contribute to the company's success, which basically means eventually your success. So thank you so much. If you have any questions about Terraform, open source, DevOps, whatever I can help with, you can reach out through a mail, LinkedIn, or Twitter, and I'll be more than happy to help. Thank you so much.